Okay, today on Spongebob 19, we're going to basically factor trinomials. Now, factoring is basically returning to something to what it was before it was multiplied. And let's look at the idea of multiplying binomials. If I'm multiplying two binomials, say 2x plus 1 and 3x plus 2, okay, and I FOIL this, I'll get 6x squared, and I'll get a plus 4x. Here I'll get a 3x, and lastly I'll get a 2. And then you combine like terms, you end up with a 6x squared plus 7x plus 2. Okay. When we factor this trinomial, what we're attempting to do is to go back to the original two binomials. So that's the process today. How to go back from a trinomial to two binomials. Okay. So I'm going to show you the methods for doing that. So these, we don't have to preserve the integrity of the original problem, which is good. We're going to first put two binomials here, since this is where we're going. So we'll start off with two binomials. We may have to put some more binomials here, but we'll see if this works. Next, to figure out what this used to be, I'm going to look at the first term right here, the 2x squared. 2x squared, I'm going to assume that used to be the first of the FOIL, first. So I'm going to say that used to be 2x times x. So it's like we're reversing the FOIL, undoing the first, the outside, the inside, and the last. Next, I need to reverse the last part, which is the 2 here. Now, here's the problem. 2 used to be 2 times 1, or it used to be 1 times 2. I don't know which one it was. If it was 2 times 1, the 2 would go here and the 1 would go there. If it was 1 times 2, it would be 1 and the 2 there. Since I don't know which one it used to be, 2 times 1 or 1 times 2, I'm going to try both and see which one works. So let's try 2 times 1 first. 2 times 1. Now, to see if that works as the right last number, I'm going to do a quick outside and inside. So inside, this makes 2x. Outside, this makes 2x. Okay. Now, what signs to put on these? So I'll put positive, 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 negative, negative, negative. Okay. The way that we find out is we look at this right here. This plus means that we need the same signs, either negative, negative, or positive, positive. I just don't know which one. So I'm going to try positive, positive, and see if that works. If I try positive, positive, this becomes 4x. Okay, so that's doing the outside and the inside. If this matches this, we have the right combination. And obviously, this doesn't match, so we don't have the right combination. So I'll write another set of parentheses here and do the first, which is 2x times x. Okay, that's the first. And then let's look at the last again, the 2. 2 times 1 didn't work, so I'm going to try 1 times 2. 1 times 2. And let's see if that works. So inside we get 1x. Outside we get 4x. And we want the signs to be the same, and we want to add up to 5x. So signs, same signs that add up to 5x. Well, if they both were positive, this would be a 5x. So this is the right combination right here, the 1 and the 2. So a plus will be first here, and a plus will be second here. So if this is plus plus, and plus plus is there. And we're done. That's it. 2x plus 1 and x plus 2. This is the right combination. Okay, let's try this one here. Let's find out what this used to be before multiplication. So I write two binomials, get it ready. And I deal with the first, which is the 5x squared. That used to be 5x times x. So we multiply 5x times x, you get 5x squared. So that's the first. Now, let's deal with the last, the 4. Now, the 4 has lots and lots of combinations. You have 1 times 4. You have 2 times 2. And you also have 4 times 1. Those are lots of combinations there. Okay, so let's start off with 1 times 4. See what happens. So 1 times 4. Okay, start off with this one, and we get a 1x here, and outside we get a 20x. So we need to use same signs on both of these, and we need to get a negative. So those are the same signs right there. And when I put them together, I will get a negative 21x. That doesn't match at all. Okay, so the 1-4 combination didn't work. The next combination I'm going to try will be the 2-2. So again, first we got 5x times x. 5x times x, that's first. And let's try the 2 times 2 combination. So 2 here and 2 there. And see if that will help us. So inside we get 2x. Outside we get 10x. We want the signs to be the same, either negative, negative, or positive, positive. Because plus means same signs. Let me write this down here. Plus means same signs. And we want to get a negative 12x. So if I use same signs here, negative, negative, that does become a negative 12x. So I found the right combination. It was the 2-2 combination. So the first one will have a negative, and the second one will have a negative. So the first one has a negative, the second one has a negative. And that's finished. Okay, number 3. Again, this is a trinomial. It used to be a binomial. We're going to figure out what that binomial, the 2 binomials were. So let's look at the first term, which is the 3x squared. I'm going to say that used to be 3x times x for the first. Now let's look at the last term, which is 2. Now 2 has a couple of choices. We have a 1 times 2 and a 2 times 1. So we have a couple of choices there. Put in a little box here so you guys can kind of see it. I'm going to try the 2 times 1 first, see if that gets us what we need. So 2 times 1. Okay. So then we'll do the inside and the outside. So this will be 2x here, and this will be 3x. Okay. Now we have a negative here. A negative indicates that the signs need to be different. One needs to be positive, one needs to be negative. And if I make one negative and one positive, right here, one negative, one positive, that becomes a 1x if that doesn't match the 5x. So that combination does not work. So the 2-1 doesn't give us anything. So we're going to try the 1-2 next. So first is 3x times x, okay, pull the 3x squared. Lastly, we're going to do the 2, and I'm going to try the 1 times 2 this time. 1 times 2. Okay, let's multiply the inside. We get 1x. Multiply the outside. We get 6x. So 1x and 6x. We want to have different signs to give us a positive 5x. Different signs, one negative, one positive. I'm going to put the negative on the 1 and the positive on the 6. If I put the negative here and the positive there, that will give us 5x. When you add them together. Okay. And that's what we were looking for, positive 5x. So in the first one, we need a negative. And the second one over here, we need a positive. So negative, positive, there's a negative, there's a positive, and we're done. That's what it used to be before multiplication. Okay, let's try this one. We'll start off with the 2 binomials and the 6x squared. 6x squared used to be, start with that first. That used to be 3x times a 2x. 3x times 2x. Now, let's go to the last. The last is the 3. We have 2 choices on 3. 3 used to be 1 times 3 or 3 times 1. And notice that I'm not considering the negative. It's not a part of me breaking up 3. We'll use the negative later. So let's try 3 times 1, see if that works. 3 times 1. Okay, so inside we get 6x. Outside we get 3x. And according to this negative here, they have to have different opposite signs. One has to be negative, one has to be positive. And we got to get a 7x, negative 7x. And the closest I think we can get to that, if I use negative here and positive there, that's a negative 3x. And that's not very close. I mean, that's not negative 7x. So let's try this again. 3x times 2x. Instead of the 3 times 1 that didn't work, I'm going to try the 1 times 3. So 1 times 3. Let's see if this has any. This gives us any results. 1 times 2x is 2x. And the 3x times 3, that's 9x. Okay, got to have opposite signs, and we want a negative 7x. So if I use opposite signs, and to get a negative 7x, I would have to have a positive here and a negative there, because this combination would give me a negative 7x. So I need a positive first, and then a negative. So positive here, and then a negative there. That's it. Okay. Number 5. Okay, number 5. Again, I want to factor this into 2 binomials. And we'll deal with the first term, the 2x cubed. I would say that used to be, 2x squared. That used to be a 2x times x. If I multiply the first terms, I will get 2x squared. Now, the 3, which is the last term, that was either 1 times 3 or 3 times 1. Okay, I'm not sure which one it was. So let's try 3 times 1 and see if that works. 3 times 1. That gives me 3x. And the outside, that gives me 2x. Okay. Now, according to this right here, this positive, these signs need to be the same. And we need to get a negative 7x. So the same signs I'm going to try are negative and negative. If I combine those, I get a negative 5x, which does not match. So the 3, 1 wasn't the right combination. So let's try 2x times x again. And instead of the 3 times 1, I'm going to try the 1 times 3. Okay. So inside, I get 1x. On the outside, I get 6x. Okay. And again, I want to use same signs, but I want to get a negative 7x. So let's use same signs here. I use a negative and negative, same signs. And that does give me a 7x. So this was the right combination. A negative first and a negative second. Negative first, negative second. And that's what it used to be before it was multiplied using void. Okay. Next, these right here. These are basically binomials, and they're called difference of 2 squares. I'll kind of explain where they came from and where the name came from. Well, when someone multiplies two binomials that are conjugates, let's multiply two binomials that are conjugates. Those are two binomials. We're going to multiply that using FOIL. We get x squared, negative 3x, we get positive 3x, and we get negative 9. These two cancel, and we end up with x squared minus 9. This result here of multiplying conjugates together gives us what we call the difference of two squares. The difference is actually the negative sign. That's the difference. The two squares are on the left and right side. Now, that's very important that our result is two squares, because that's going to be the way that we're going to go back and get the original two binomials. So let me show you how to do that. All right, so this is a difference, and we see that all this are squares. These are squares. So what I'm going to do is take out a square root, and I'm going to put the first square in here, 16, x squared here, and 25 here. I'm going to take the square root of both of those. Square root of 16 is 4. Square root of x squared is x. Square root of 25 is 5. Okay. Since you get these two terms here, we're going to write these terms as conjugates. So we're going to write our two parentheses here. And I'm going to say 4x plus 5 and 4x minus 5. And this is what this used to be before it was multiplied using FOIL. Okay. And again, you got to have squares in order to do this, because you can't always take the square root. Sorry, you can't take the square root of a number, then you can't get this result. So here, difference of two squares. So I'm going to take the square root twice of 121 and x squared and 255. The square root of 121 is 11. The square root of x to the second power is x. The square root of 225 is 15. So I'm going to make conjugates out of my 11x and my 15. So let's write the two binomials. 11x plus 15, 11x minus 15. And that's what this used to be before multiplication. Okay, let's try the last one. Okay, we have two squares, and there's a difference. So difference of two squares. Let's pull out a square root. So we put two squares in there. So this is 81 x to the 4th and 144. The square root of 81 is 9. The square root of x to the 4th power is x to the 2nd power. The square root of 144 is 12. So we're going to make conjugates out of those. And we'll get 9 x to the 2nd power plus 12, and 9 x to the 2nd power minus 12. And that's done.